Hey, good to see you. Thanks for coming. This is another episode of Wireframe brought to you by Design Systems House. I'm your host, Donnie D'Amato, and today we're going to be talking about something called Tokenscript. So this is what I was alluding to yesterday in the show because there was a lot of news that happened last week where all the things were going on, and that was something that was announced at Penpot Fest, which is another event that was going on last week. The folks at Token Studio launched or I guess announced this at some point late last week, and has a whole bunch of resources about it that immediately I'm interested, and then I'll explain why I'm probably more interested than I would normally be interested in when it comes to tokens overall, because admittedly, this was my idea. That's right. I'm just going to say it. This was originally my idea. And we'll get into why I think that in a minute. But I do want to go into what they presented, or not presented, but more so what the resources that they linked to. I don't have a link to the presentation. I don't know if it's available online or anything like that. I did see some photos, some LinkedIn posts and things like that that were linking to these things. So we're just going to go ahead and take a peek at what they have to offer. Actually, you know what? Before we do that, though, we haven't talked to the AI in a little bit. You know, maybe the AI has some insight into some of this stuff. Who knows? So let's give it a shot and see if there's some opinions over there. Hey, in the realm of design systems, have you heard of something called Token Studio?
Yes, Token Studio is a design tool created by InVision, a prominent UX UI design platform. Token Studio is an editor that allows designers to create and manage design variations, or tokens, in a design system. It provides a visual interface for defining color, typography, and space styles, as well as creating patterns, shadows, and other complex design elements. Token Studio integrates with other tools in InVision's platform to create consistent and scalable design systems.
Okay, so Token Studio is not part of InVision as far as I know. I mean, InVision's kind of defunct at this point. Token Studio ended up being a company that was spun off from the Figma Tokens plugin. Does that sound more correct for you?
Yes, you're correct. I apologize for the confusion. Token Studio was initially a plugin developed for Figma, a popular design tool, and later spun off as a separate company. It does not belong to InVision.
Okay, great. Now, did you know that Token Studio has recently announced this thing called Tokenscript? Have you ever heard of that?
Yes, I am aware of Tokenscript. Tokenscript is a new language created by Token Studio designed specifically for designing and implementing design systems. It is meant to offer a more declarative and type-safe way to define and manage design components and variations within a design system. Tokenscript is intended to be a powerful tool for designers, developers, and product teams working on design systems, offering a more efficient and consistent approach to creating and maintaining scalable design systems.
Okay, good. Now, in the realm of design systems, have you ever heard of something called token operations?
Yes, I am familiar with token operations in the world of design systems. Token operations refer to a set of operations used to manipulate and transform design tokens, such as colors, spacing, and typography within a design system. Token operations are used to create variations of design tokens and generate different design system outputs. They typically include functions like multiplication, blending, and other mathematical operations, as well as functions to create gradients or patterns based on design tokens. Token operations are used to create different design variations within a design system.
Okay, and how are token operations different from the Tokenscript that was just announced?
Tokenscript and token operations are two different concepts in the world of design systems. Tokenscript is a new language designed for defining and implementing design systems, while token operations refer to a set of operations that manipulate and transform design tokens to create variations of design system outputs. Tokenscript is a tool for defining design system rules and constraints, while token operations are the operations used. So they are different concepts with different purposes in the design systems world.
Okay, well, that's what we'll take about that. So we needed a little bit of coercing to get the sidekick to understand what we're talking about today, but actually ended up talking about some really interesting stuff there. I mean, I must have found out the Tokenscript repo as well as the token operations repo, which, full disclosure, that was my project a few years ago. We're going to talk a little bit about that, but I do want to get into the actual resources that were shown or at least provided in these blog posts. So we're going to go into Token Studio's repo and take a look at the Tokenscript interpreter. And here's the interpreter. It's underneath the Token Studio GitHub repository or GitHub organization, I should say. And it says that it's a TypeScript interpreter for Tokenscript, or this thing is the interpreter, which is a domain-specific language designed for design token manipulation, computation, and color space conversions. Tokenscript provides a powerful type-safe environment for working with design tokens and modern design systems, etc. This is a early release. So let's take a look at some of the stuff that they're offering here. So you could see that Tokenscript has this language where you could declare a variable with a name, and this is going to be a string called primary button. You could declare a count of 42 is visible as a Boolean of true. You could also have some more design-specific types like number with unit, or a color that in this case is a hex, or a list that has like comma-separated kind of string over here. Apparently, color management has some functions in here. You could have this OKLCH ramp that has a yellow that turns into OKLCH and then makes values and turns it into a list. So if you wanted to make, I guess, this color here, which is assigned to yellow, you can automatically make it OKLCH and then put that as a ramp and put values in there as a list, and you can kind of go through that and I guess make these into hex colors or something of that nature, I guess that's how that works. Mathematical operations, you could time some things together. Apparently you can also, times it with units. That's just fun. Number with unit, where you're adding these together, I'm very interested to know what the fuck's going on here. I don't know how you figure this out, because rem is at the client side. So, and percentage has to do with the current percentage based on where the rem is, at least in CSS. So I don't know, unless it's like percentage of this. So we're basically saying like, maybe we're going to assume 16 plus 1 is 17 plus 10% of the 17 equals 18.7. Maybe that's what's going on there. I don't know. I'm a little afraid of this particular thing right here. Control flow here, you could do some conditional stuff. If this, then create a new variable with these things here. Apparently do a loop, which sounds kind of scary in my opinion. And then you could do data structures with lists, right? And then reference, right? So you could do aliasing. This is what this is kind of talking about here. You could reference colors primary, assign that to a primary color variable. You can do this thing here. You could also add these two things together, I guess. So you have a base unit and modifiers. You can put that together like that. That's nice. Some setup specification stuff. I'm not going to go too much into this because this just looks like how you would prepare this for writing this in JavaScript, because again, this is an npm install here. And because it's an npm install, this is specifically a JavaScript language thing. So, you get the general gist, right? They've effectively written a language that is meant to specifically support the kinds of manipulations and transformations that we see in token management all the time. One of the most common, and it was actually in the DTCG discussions was taking a hex code and turning that into its hex plus some alpha, right? So if you have some hex code that's like, I don't know, FFCC00, and you wanted to add a little bit of alpha to make that into a new token, the community wanted an easy way of doing that. And this was discussed in one of the discussions years ago, where one of the ideas was to have this object called operations. That wasn't my idea, that was somebody else's, to have this operations object that would then declare things to do against the value that's at that token. And I'll show you what an example of that is in a minute. And my big feedback initially in that was that, well, if we had a key that was like alpha on this object here, that means that the spec has to define what that operation is internally, where all of the people who are implementing that spec needs to also define the computation for alpha in their own ways, whatever the heck that is. And also, there's now only that one way for everyone to do alpha, where maybe they don't want to have alpha done that way. Maybe they want alpha to be done in some different way. Maybe they want to have hex as an alpha, like, which is totally possible with the 8-character hex. So maybe that's something you want to do. Most people don't, but maybe that's something someone wanted to do. So now we're kind of stuck into this one particular implementation of what alpha is supposed to do when a hex code comes in. So I thought that to be like not great. And unfortunately, the entire color specification kind of turned into that. The color specification is now very, I'll call it rigid, in terms of what it expects for a person to implement, right? What it used to be early on was you could just put a string in there, right? Put the hex code in there, put your RGB value in there, put whatever you want in there, right? And it was up to the implementers to say, okay, this is an RGB, I'm going to, split that off into the right segments such that it displays properly in my interface or in my UI or something of that nature. And I felt that to be more aligned to what we've been doing in CSS for decades now, which is like, here's a string, it represents a color, and you got to do some work to make it easy for the people who are adding the colors to implement these in the systems, right? Someone just wants to write in a hex code, they know the hex code, they just copy and paste it from somewhere. Just go ahead and put the hex code and we're done, right? Or in some cases when people just want an RGB and they feel more comfortable with that, that's fine, right? But we've been using the same syntax for a really long time. Why are we changing it? Because the ergonomics are not there. All of the change that happened with the color specification was meant to help the systems, which is weird to me because the systems are computers. There's still humans involved in this. So when a human goes into a token file trying to figure out the curation of these values, I don't want to have to parse it into a new color value just to put it into this file. I thought that was silly. And yes, you could make tooling, but then you have additional tooling in your tool chain just to manage the stuff. I just thought it was so ridiculous. I felt that it was a lot better for it to be human maintainable, right? Where a person can actually just open up a token file, go to the token that they want to change, make the change in a human readable way, and then save the file and go, as opposed to having a tool chain to change a value. I thought that was just too much. But ultimately, the folks that work on the token specification adopted the new color specification, which I don't know how they're going to do the rest of the stuff. Like if color was that complex, I don't know how they're going to do topography. And I've been keeping a closed eye on what's been going on in the discussions, and I don't see anyone really bringing this up, nor do I see it really pushing forward much other than the Token Studio folks. The Token Studio folks have really dived into the community group and are really pushing it, but I'm a little afraid of that because it's aligning to their own agenda. And if it aligns to their own agenda, then it kind of like goes, it becomes less of a community and more of a company pushing this. So not so great. But a little bit of a tangent there because I want to talk about this is a good idea, fundamentally speaking, because again, like I said earlier, we want to make changes to existing values in kind of systematic ways, right? Taking a hex value, turning it to an alpha, right? So something like this is absolutely going to support something like that. The problem is, and this was one of the big kind of pieces of feedback that I got when I was working on token operations, was the criticism was that, oh, it only works in a JavaScript ecosystem. What if I wanted to make it, a token token management system in Rust, or I wanted to do it in Python, right? Like, how could I, if it's just in JavaScript, then I'm like limited to just using JavaScript. And I saw that. I knew exactly what that was all about. And I'll explain what I did to get around that. But for this is its own language, right? Which you have to learn, which is reasonable in this, because mine also has effectively its own language. But the thing is, you need to include the interpreter in the toolchain, and that's specifically written in JavaScript. And granted, like, you could write another interpreter for Python or all the other kind of stuff in there, and just like, do you want to? Sounds like you need a lot of interpreters just to get this language, just to change the hex color, and especially since it's entirely possible, again, that alpha change that's embedded into the token script isn't exactly the alpha change that you want. You have to hopefully make your own. And I don't know how customized the token script abilities are, because again, looking at those methods they look like there's just like some really nice, helpful utility stuff, but I don't know how custom you could really get. And that was one of the main objectives with token operations. So I want to show you a blog post that I wrote a few years ago, which is called Token Operations. And there was a presentation that I did at Design Systems Wednesday day. That was kind of like a mini conference that Maria, who does Design Systems Wednesday, put out a few years ago. And I did a presentation on token operations then, which is actually available online. One of my very few presentations that is available online on my website. But this is the blog post that accompanies this. And I want to show you a couple of things. So the first thing that was introduced, that I talked about earlier, was this idea from Jerome Farnham. And here's what a token was looking like. You'd have a token name, you'd have the special dollar value symbol that would indicate what the value of this token is going to be. And then you have the type of token, so this is like a TypeScript sort of looking thing, but you would say this is a color, so you know what this is supposed to be. And then the thing that Jerome was suggesting was to put this new special operations thing as another key on this token. And operations would be an array, and the array would have a couple of different things to do. So you would change the hue by -20 here, you'd add alpha by 0.3 over here. So it would show like the things that you would want to do to this initial value that's up here, all the changes that you would make. Okay, so you wouldn't have to encode it here, you could just have the operations do it. And I had two major flaws with this, right? The free-for naming was the first problem, and I mentioned this earlier, right? If hue is defined by the spec, we have to wait for the spec to implement hue. And then we also have to wait for the people who are implementing the spec to introduce hue into their implementations, right? So Figma, would potentially adopt this specification, then they would also have to implement hue when this comes out or is allowed or whatever it is, and you'd just be waiting for these things to be approved and implemented over and over and over again. And I really didn't like that. And then number two was the custom functions thing, which is like, well, what if I wanted like, I don't know, sepia? Like, how do I make the sepia out of this? Is that, do I have to wait for people to agree how that works or something like that? Like, I can't just make sepia happen. I have to take this value, make another token, and then convert this elsewhere outside of this ecosystem to figure out what this value for sepia is. And then it's hard-coded. And I don't have a way to reference this color to make it sepia, right? So those two things were immediately, for me, major flaws in just waiting for definitions to appear for this. So what I wanted to do instead, and I know this looks a little bit daunting, but I wanted to make the operations more declarative, right? Where you are effectively going step by step and making changes to this value to ultimately make the final modification. And when you do it this way, you are in complete control about the way that this value starts, which is what's up here, into what it ends up being at the end. You are in complete control, right? It's all completely up to you. So in this particular example, in operations here, this particular operation kind of says, okay, here's an incoming value. This is going to be the 0.5 of the alpha. The next operation says, okay, match the value, so taking the value that's up here, and we're going to do a string match on this, which is going to match the first two characters missing the pound sign. So we're going to match the FF. And then it stores it in a variable called $1 internally. And then we're going to use that over here. It does the same thing for the next two, right? So the next the FC, and then the next one here, the 00. So that stores the results in $1, $2, and $3. Then we could use those variables that are stored in these positions. $1, we could parse the integer and turn it into a base 16 integer, which is what we do for hex, to turn it into like an RGB value. So we do that 3 times for each one of those sections, the RG and a B. And then finally, what I do here is I concatenate all of these values together. So I'm basically going ahead and I'm concatenating the results here, which is stored in 4, 5, and 6. So I'm going to take the 4, the 5, and the 6. I'm also storing the 0, which was up here. This is the first one here. Storing them in the 0. And I'm concatenating them all with commas. Okay? And then finally, I'm going to put the result that was in here, which is in position 7, inside of an RGBA function. And then the final operation here is returned as the new value for primary color overlay. So that's how this works. This array here is going step by step and storing the result of the operation as a position, so like a position 1, position 2, position 3, those are what's coming in here, to be used potentially in later operations, right? So I could do string concat and things like that, okay? Now, it explains a little bit more about what an operation looks like. This is actually exactly what we kind of went through here, is that, it's stored at $0, the FF is stored at $1, et cetera, and finally it's storing this whole thing as 8, but it's also returning the value, okay? And I think before we get into this, one of the things that, again, was a piece of criticism was, wait a minute, these are all JavaScript things, right? String match is a JavaScript thing, math parse int is a JavaScript thing, string concat, JavaScript thing, right? Like, hold on a second, these are JavaScript things. Why is it specific to JavaScript? What happens if I want to write it in Rust? Well, here's the thing. All of those things, string match, the parse int, all that stuff, all of those things, as far as I'm aware, are things that are easily replicatable in other languages, right? Like doing a string concat in Python, you could absolutely do, right? That's not something that's hard to do. So what I was trying to suggest in all those initial operations, like matching and things like that, was that we would need to define what those things do, those low-level operations, define all the low-level operations such that people could create more complex operations in whatever ways they wanted to do. And in many of these cases, especially in the GitHub for token operations, I kind of call out, like, look, all the math stuff, that mostly exists. All the string stuff mostly exists in this stuff. And generally speaking, what we're doing is we're just doing string and number manipulation for a lot of these tokens. There isn't a lot of complex stuff when it comes to these operations that we're really trying to do. And it actually is possible to get to complex things using token operations. And I have an example of this coming down over here. So yeah, reusing common operations. So one of the things that I wanted to do, because the syntax is crazy. Do not get me wrong, it was a very big piece of feedback was this syntax is too much. It's very overwhelming and not easy to follow, et cetera, et cetera. I totally understood that, but that is by design based on this being a programming language that sat inside of the JSON. That was the whole idea, that what you were going to do with the token moved with the token, as opposed to it being at some other point in the life cycle, right? So that you could see that something was going on. What I wanted to do, though, is to abstract this out in a way such that you could have reusable operations. So as an example here, you could say that there was some operation that looked like that up there that you could just reference the operation, like, hey, I'm going to do a hex opacity operation, and here's an argument that I'm going to pass into it, and it would just do that operation on this value, and it would give you the new value with this alpha on it for this token, right? And this is totally arbitrary. There wouldn't have necessarily been, and technically there is, but there didn't necessarily need to have been a token operations package that had all of the, blessed operations in it. This is quite literally just an example of the ability to create a package that would have operations that you could reuse or people could bless or whatever. But ultimately, this operation would be the thing that looked like this, that no one would have to see themselves unless you really wanted to. So anyway, another thing that we have in here, let's see here, what's different from this? what was this explaining? Yeah, this is just talk about the operations parser. Okay, so I wanted to also show, because I realize that this is not in here. I wanted to show the actual repo for token operations. I don't know why I didn't link to it in the post. Bear with me. Let's see, GitHub. Okay, token operations, yes. The first thing that I have up here, because it is the thing that I'm most proud of. Okay. So this does talk about here, like using it in JavaScript. And because this is, again, it's supposed to be a proof of concept, but you can, we can make interpreters for any of this stuff. But again, we saw this already. You would have this idea called operations that would be on the specification here. And then here's a smaller example, actually. Let's see if I make this a little bit bigger. Yeah. So here's a smaller example that's not as overwhelming as trying to add a hex code. In here, let's say we start with this type dimension and the value's 2rem. Okay? And what we want to do is we want to increase the font size based off of this default. Okay? So we could start with some typography base size, whatever the heck that is. Maybe that's some alias that's sitting over here, and that's stored at $0. And then there's a typography scale that's stored somewhere else, again, $1. And what I could do is to make the scale, I could use that math function, math_pow, so it's to an exponent, and we could use the value at $1, so the scale here. So we're going to raise that to the power 2. We're going to store that at $2. And then we're going to do this in CSS. So we're going to do string concat and use a calc, right? We're going to take the $2, so that math_pow thing that happened over here, times the $0, which is the base font size, and that's going to do effectively what this is doing right over here, right? This calc math_pow, typography scale, base size, and it makes the font size step up to the second level, okay? And that happens all in this operation that's right here, right? The other thing that you can do is, like I mentioned earlier, you can have this like import operations operation that just imports it from a place. This is, in this case, token operations, that does that operation using these things. And you would input these things as like placeholders or arguments, right? So here's another example of, well, actually, this is saying that composite tokens, like what shadow is and what color now is, don't work in the current implementation here because it doesn't know what to do with an object value. It only knows what to do with numbers and strings. But this explains kind of what the anatomy of an operations array would be. You have the ability to put a primitive value there, which in this case would be stored at $0. You could put aliases in there, so it can grab that alias and resolve it and store it as, the number 7 in $1. And then you could do an actual operation as an array, right? So you could take math add, you could take $0, which is 42, $1, which is 7, add it together, and it's stored in $2. And this is the exact same thing of you doing something like this in JavaScript, right? You can go ahead and do this, and it also stores it as dollar value for the new token. Here's the command array, et cetera, et cetera. And here's a couple of things that I've added to the language, right? So so the commands are based off of JavaScript native functions. So they inherit from number and math and string. So math max totally exists. String is slightly changed to allow for this context. So it's, you would do a string repeat, and then the next argument is effectively this, and then this is the argument that goes into repeat. So there'll be the same thing as O repeat 3, which returns OOO. So it's a little bit slightly different than what math works as, but ultimately I wanted to keep these things the same kind of syntax. Some methods that deal with this stuff would return a more complex value, like a list. I didn't want a list to appear because we want to store each value into an individual slot. So a thing like string split might be a little bit different, or specifically like a thing like string match only returns the first match as opposed to returning lots of matches. But I had something called string capture, which was effectively doing that. So instead of having a string match work here, string capture is again only returning the first capture. And then import operations was like a special one for the case of being able to import operations. So like I said earlier, let's say that we had this operation that I was defined here. I would be able to import this as an operation as opposed to using and coding this directly. So talks about aliases here. The root operation set is this kind of idea of being able to use the value off of here. Okay, yeah, so here's the actually import operations thing. So inside of a thing called hex value alpha rgba.json, and I'm using JSON 5 here just for comments, you would have this array, which would be an operation. And you would have all these operations, which again is doing this hex alpha thing. And you can just do this import operations operation in the array, point to it, give it the arguments, and it would do this work to then create an overlay for whatever this color is. And that was one of the options that I had in here. Another thing that I think I had in here, oh yeah, so this is really complicated. This one in particular is trying to figure out to use either white or black based on the value that's coming in for this for primary color. So you could do this. This would be effectively control flow. And I had an operation that was specifically trying to manage that using some calculations that are based off of WCAG specifications and YIQ, color math, just some crazy, stuff that's actually happening in here. But ultimately, you don't need to code this. You could, or we in the token operations could have composed this as another operation to just give you. Which actually I think I did. Binary if string I think totally exists as an operation. Yeah, it totally does. And there's a community group issue that introduces this as a possibility. So yeah, so this existed as a option that people could do. Here's the binary if string thing that effectively says, okay, if you give it these two values, it figures out which one it should return based on being true or false effectively. Here's the hex value one. Here's YIQ brightness, which there's a lot involved in here to make it work. They have the special values in here. Rem calc, which is also in there as well. So these are some sample operations that I had. I'll bring back to me here. So again, the purpose for all of that being complex, and I know again it's a very unique kind of thing, but it was necessarily complex, but I tried to make it accessible because I wanted the definition of what's going on in a token to move with the token, right? Even if it's referencing somewhere else that's somewhere else in the project or something of that nature, that's okay. But as long as it moves with the token. In the case of Tokenscript, it doesn't sound like that the mutations are happening with the tokens, right? You would have some token file in JSON, right, that you would import into the script and then do a whole bunch of mutations, right? And then go into your consumer of choice, right? The web, Android, Figma, wherever, right? So you have this thing in the middle that needs to interpret the token script that needs to be there, right? And from a business standpoint, that sounds great for Token Studio, right? Because it's injecting itself into the ecosystem where it needs to be needed. But from an open source, open standard point of view, it made more sense for me to cut out the middleman and say, look, the operations stay with the tokens. And then you take the whole file and you are giving it to a consumer, Figma of that nature, right? Or something of that nature, where Figma's like, okay, I know what token operations do. I'm going to go ahead and do whatever operations that are defined with these tokens on this stuff to get the final values that are going to go on across this page, right? So in a way, you could argue that token operations isn't much different from the token script, but again, I think the big benefit is that for token operations, the operations stay with the tokens. For token script, it doesn't sound like the tokens stay with those mutations, right? You're going to have this black box of stuff that's happening that, you know, must go through there. Instead of, again, making an interpreter that is agnostic to the actual operations that are happening, like hex and ifs and things of that nature, right? Like, you know, in token operations, you just have these low-level things that are repeatable in any language, where in token script, right? Where is it? Did I lose it? Oh, it's over here. No. Where is it? Oh, this is it. No. It looked like mine. In Tokenscript, because we have, where is it? I'll find it. Here, yeah. Because we have this thing in Tokenscript, which makes a ramp from the yellow, like this list is dynamic. It's not part of the tokens that you are maintaining. It's completely created out of like thin air, effectively. And it ends up like asking a question about where the source of truth is, right? Because again, in token operations, the source of truth is in the tokens with the operations, right? When you have another layer inside of there, this, you know, the resolver before this, you have this other layer that's generating all this other new stuff. Where's the source of truth? And that's what I'm worried about in here, right? Because then you get lost about where did these yellows come from, right? At least in token operations, if we're going to go ahead and start generating values of yellow, you're defining the list inside of the token file, and that can be, you know, ported over to different places. That was the big benefit, right? But admittedly, from an ergonomic point of view, right, Tokenscript is more clear to write, right? It's definitely more user-friendly in terms of writing what I want to do with the mutations, right? When you look at token operations, it looks very unwieldy. There's a lot of like regex stuff to parse things out and to make the operations. But again, that wasn't the purpose of token operations. Token operations was meant for a small subset of people to write operations so that other people, the larger practice of design systems, could import those operations and use them to however they want, right? And importing an operation is a lot easier than trying to write one yourself, by far, right? That was the main objective here, was that importing an operation would have been the main way of using operations, right? And if the question was, well, who's making the operations? Anybody could make the operations if you really wanted to, right? And I have some examples, right? But that was the thing that I was trying to push. And look, I'm glad that there's a possibility where tokens can be mutated after the fact in a workflow. I'm just worried that it makes the workflow more complex. That's my big feedback, I think, when it comes to Tokenscript, is that we're introducing more and more tooling. I mean, you know, this is another thing that's happened to me recently where I was talking with a group of peers about a direction to take on something, and the group all wanted to add a build process to the project that I was working on. Meanwhile, the project works fine without a build process, totally fine. But because the organization was so, I guess, used to having a build process for everything, they're kind of like, why doesn't it have a build process? And the reality of it is you could add a build process, it's just going to add complexity. Maybe it helps you out, but then, you know, I think of this as like Webpack back in the day. Like, Webpack didn't have any defaults. You had to figure out Webpack in order to make it work, which didn't make any sense to me. Now we have something like Vite, which Vite just has sensible defaults and it works. That's how it should have always been. So similarly, I think that there could have been sensible defaults for, you know, things like token operations. A imported operation would be a sensible default for your hex to alpha, and you just get that, right? Or you could dive in and start writing your own operation if you so choose. But forcing folks to learn a new language just to go ahead and do this, I don't know if they're going to have, you know, reusable imports, and, you know, if there's going to be a problem with, you know, writing in Python or Rust, if that's something that people want to do. But look, ultimately, like I said, I wish the folks good luck in the endeavor. Me personally, I don't see the benefit of what they've done in comparison to what I've done. I'm a little bit biased, but admittedly, I think my approach would be more aligned to a source of truth as opposed to wondering what my tool chain is doing. But you know what? Let me know what you think. Take a look at the Tokenscript from Token Studio. Take a look at the token operations. In fact, I didn't realize that there's a, I don't know what the second issue is, because I know what the first one is. The first issue was that the syntax is too, oh, I remember this. Okay, can token operations help with color spaces? So I explain in here how it could help with color spaces to this person because they were asking about it. Yeah, so anyway, but let me know what you think in the comments down below, or if you want, you know, totally up to you. You could, of course, join the Discord, which is down there, discord.ds.house, and you can ask some questions about token operations in there. Admittedly, I don't remember much because it has been 2 years since I was working on this, and because it kind of fell flat more or less, I stopped working on it, you know, for, you know, things like mise-en mode, which is effectively exactly the same time that started coming out. I probably would have continued working on token operations if mise-en mode wasn't such a big deal for me. And what, you know what, maybe I return to mise-en mode and, sorry, not mise-en mode. Maybe I return to token operations if people are actually caring about that stuff. But admittedly, with something like Tokenscript, I don't think that's going to happen. You know, I think people at this point now in the year 2025 have figured out their own processes for managing this stuff. And I think looking at token operations just ends up being really overwhelming. And people just don't want overwhelming, they want easy. And I'm learning that over time, which makes more innovative solutions really hard to adopt. But again, let me know what you think in the comments down below. It's good to see you. Thanks for joining me with here today. There's no show tomorrow because we'll be at UXDX in New York. Hope to see you over there. Otherwise, I hope everyone has a good day. I'll see you next time. Bye.